Hi, everybody. Welcome to our Math 70 video lecture on section 6.5, which is graphing quadratic functions, which could be titled How to Use Desmos, because I want you to use Desmos when you graph quadratic functions. That's the whole point. Even though this is the title of the section, I'm going to say this is using graphs to understand quadratic functions. So a quadratic function, generally speaking, is ax squared plus bx plus c. And if we think of it as a function, we want to say I can choose my x and then find out the output f of x. So let me just give you an example of that. Let's suppose I have a function f of x, which looks like x squared minus 4x 6 and 2 minus 12. I could say x equals 1. So the output should be f of 1. So it's going to be 1 squared minus 4 times 1 minus 12, which is 1 minus 4 minus 12, which is negative 15. So the coordinate point xy is going to be negative 1 comma negative 15. And we've done something like this before. We've looked at coordinate points, but we've looked at them in the context of linear functions. And now we're going to be looking at coordinate points in the context of quadratic functions, which we know aren't straight lines. Let's practice another. Let's do x equals negative 2 and see what we get. So f of negative 2 is negative 2 quantity squared minus 4 times negative 2 minus 12. Negative 2 squared is 4. Minus 4 times minus 2 is actually positive 8. And then I subtract the 12. And actually, that's 12 minus 12, which equals 0. That's interesting. So that tells me that f of negative 2 equals 0, or the point xy equals negative 2 comma 0 is on the graph, and that's an x-intercept. Now let's take a step back. Now that we've seen the x-intercept, let's take a step back and talk about the 4 important characteristics of a quadratic function when you look at it visually. And these characteristics, these are going to come up again and again and again in math when we look at different functions. The 4 important characteristics of quadratic functions. The first one is the y-intercept, the initial value when x equals 0. The second one are the x-intercepts, if there are any. We've seen that there are plenty of quadratic functions that never touch the x-axis, so you might not have the x-intercepts. The third is the maximum or the minimum, because all quadratic functions turn around. They might look like this, in which case you have a minimum point, or they might look like this, in which case you have a maximum point. And in terms of understanding situations that involve quadratic functions, knowing the maximum or the minimum is a super useful piece of information. And the last point is, does it open up or open down. Right? There's a quadratic function that opens up, and there's a quadratic function that opens down. These are the four important characteristics of quadratic functions. All of these characteristics can be seen very easily when you graph the quadratic function. So let's go ahead and do that. I'm going to hop over to Desmos. And we'll use that quadratic function that I just put on the paper. Here we go. So my function, I'm going to actually give it a function name f of x. And one of the reasons that's nice is that's going to allow me to do things with it really quickly. It was x squared minus 4x minus 12. Zoom out a little bit, and let's answer some of those questions. So one thing about this particular picture is it's kind of squished. If you go up here to the wrench, you can actually change your graph settings. Looks like I don't gonna need to go all the way down to -31. I'm just gonna go to -10 on the left and maybe 10 on the right. Same function, but I changed my scale. Right now it's steps of 2 on the x-axis and steps of 10 on the y-axis. So it's a little easier to look at. So let's get our information. First is the y-intercept when x equals 0. And how do you figure that out? You just put 0 into your function. There it is, -12. So the y-intercept is 0, -12, which means when x equals 0, y equals -12, or the initial value is -12. And it's really easy to see if you click on your graph. Desmos usually gives you x and y intercepts for free. There it is, 0, -12. Let's look for x-intercepts. And as we can see from the graph, there are two of them. This is when the y value equals 0, -2, and +6. And we know we can always find x-intercepts by factoring. So I bet if I factored in x plus 2 times x minus 6, I'd get the exact same graph because the factors correspond to the x-intercepts. It's -2 and 0, and 6 and 0. Let's find the maximum or the minimum point. Well, looking at this graph, I'm going to be looking for the minimum value and where it occurs, which means the x and y coordinates of that minimum. Clicking on the graph, again, Desmos will generally give you those points. And I have to click again because I already forgot. Looks like 2 and -16. And coordinates are x, y equals 2, -16. And here we're going to introduce a piece of vocabulary, which I will also put on the notes. This is called the vertex of the quadratic of the graph or quadratic function. Vertex, there's a reason why it's called that. I would encourage you just to think of it as the maximum or the minimum, because that's what it is. And then the last one is, does it open up or down? And we can tell very easily this opens up. And by the way, the reason it opens up is because the leading coefficient is positive. If I were to do one little thing and take that minus or x squared and make it a negative, it would open down. I mean, it changes other things as well, but in the context of open up or open down, it just matters if the leading coefficient is positive or negative. All right, I'm going to transfer this information over to the paper because I know you're not going to have this particular function if you look at the notes later. And then we'll talk a little bit more about what each of those pieces mean and other ways to find each of those pieces. So let's graph x squared minus 4x minus 12. And let's pretend we didn't have Desmos to help us. So first we want to find the y-intercept. Let me give it function notation. So that's f of 0. So I'm going to put 0 in for x. 0 squared minus 4 times 0, negative 12. And notice those pieces cancel out, and I'm left with the c value, i.e. the constant term. When x equals 0, these pieces drop out, and you're just left with minus 12. So you can read off the y-intercept from this form of a quadratic equation. Let's say that right there is at negative 12. I'm trying to decide what side to write it on. Okay, I'm going to put it on that side. That's one piece of information. Next piece are the x-intercepts. Well, I find these from the corresponding factors. So if I'm doing this by hand, I need to factor this expression by hand. And let's go ahead and do it. Squeeze it in here. X plus gives me an x squared and a minus 12. So I need two numbers that multiply to be negative 12 and add to negative 4. I'm going to save myself a little time and say negative 6 and 2 multiply to be negative 12 and add to be negative 4. So my factors are x minus 6 and x plus 2. And I want that to equal 0. So my x-intercepts occur at x equals 6 and x equals negative 2. 1, 2, 3, 4, 5, 6. And 1, 2. Great. I'm well on my way. Let's come back to the vertex because there's something interesting about the vertex. Well, let's do it now. The vertex, the max or min. What I want you to recognize, let's take a look at the graph again, the one that's already built in Desmos, is that this quadratic function is symmetric. It could mirror over itself. And where it mirrors, this is called the line of symmetry, right? It goes right down the middle, and you could flip this graph over that line and it would still look the same. And that line of symmetry goes right through the minimum value. It goes right through the vertex. And that line of symmetry is immediately between or perfectly between those two x-intercepts. So what this means is the x-coordinate of the vertex is halfway between the x-intercepts. It's the middle point. And how do you find a middle point? How do you find an average? You take the two x-intercepts, -2 and 6, you add them up, and you divide by 2. That's 4/2, which is 2. So you take x-intercept number 1, add x-intercept number 2, and divide by 2. And this is the coordinate, the x-coordinate of the vertex. Whether it's a max or a min, it's always going to be x1 plus x2/2, where the x1 and the x2 are the x-intercepts. And that tells you the line of symmetry goes right through there. Now it's hard to say how far the graph comes down, right? So how do you find the y-coordinate? The y-coordinate of the vertex is found, the y-coordinate of the vertex is found just by plugging the x-coordinate into the function. Because the whole point of a function is if you take your x-coordinate and you put it into your function, you're going to get the corresponding y-coordinate. So let's do that. F of 2 is 2 squared minus 4 times 2 minus 12, which is 4 minus 8 minus 12, which is 4 minus 20, which is -16. So the vertex, the coordinates of the vertex is xy equals 2 comma -16. And sure enough, if we take a look at the Desmos graph, there it is, 2, -16, symmetric about that line. And let me make that a dashed line. There we go. Perfectly symmetric about that line, and the coordinates are 2 comma -16. That means on my graph, I'm going to go, let's see, 3, 6, 9, 12, 15, a little bit more right there. The last step is to ask, does this open up or down? And that's a very easy answer. You just look at the A value. In this case, it's 1. That's positive, so it opens up. And by the time we have all this information on our graph, it's also obvious it opens up because the minimum has to come up through these points, like so. And we've graphed our quadratic function. All right, let's do another example. But first, I want to tell you that for the homework, feel free to use Desmos. Let's use the technology that we have to make our job a little easier. There are some questions in the homework where your coefficients are a little bit challenging. So let me give you an example from the homework. Here we want to figure out some information, x and y, from this formula, which frankly is not a super simple formula to work with. I don't really want to have to square -3 and multiply it by 1.29, et cetera, et cetera. So I'm going to put this information into Desmos. I've got 1.9 x squared, or I think 1.29 x squared minus 0.03x. Oh, that's a plus 0.03x, and then a minus 1.25. Is that right? Yep. And let me go back to the square zoom. There we go. All right, so I can answer some questions about it. I could say, I've got these two x-intercepts. Those don't look like rational numbers. So if I wanted to find out what they were with exact values, I'd probably need the quadratic formula. It's really hard to tell, but I think we have a vertex and a y-intercept, which are not the same values. Hard to see on a graph, but that's all right. And then the homework is just asking you, what output do I get with different inputs? So as soon as you build your quadratic function as a function with this f of x piece, you can use that and just put it in. And there we go. That means that when x equals -3, y equals 10.27. I can even put that on my function or put that on my graph, and there it is. We see that it's right there on the graph. And that will help you do your homework at a reasonable rate. Otherwise, you're spending a lot of time doing these calculations on a hand calculator, and there's no need to do that. Okay, let's go back to examples. Let's do -2x² minus 6x plus 28. 28, 56 plus 56. And that's a function, so I'll say f of x. I'm going to ask you a series of questions. I'm going to ask you, what is the y-intercept? What are the x-intercepts? What's the max or min, i.e. the vertex? And does it open up or down? Okay. The y-intercept is super easy. It's just that number right there, 56. The x-intercepts require factoring if I'm going to factor by hand. And so let's do that. First thing I'm going to do is I'm going to factor out the -2 from each piece. -2 times x² plus 3x minus 28. And I'm going to box method the rest of it. I built this. -28 is 4 times -7, or 7 times -4. And so if I do an x plus 7 and an x minus 4, 7 minus 4 gives me the 3. Okay, that's good. So my factored form is -2 times x plus 7 times x minus 4, which tells me that my x-intercepts are -7, 0 and 4, 0, the corresponding solutions, or the solutions that correspond to the factors. The vertex, well, the x-coordinate of the vertex is halfway between -7 and +4. So I'm going to add those up and divide by 2. -7 and +4 is -3. So the x-coordinate is -3/2. And the y-coordinate, I just take that -3/2 and I put it into my function. So -2 times -3/2 quantity squared minus 6 times -3/2 plus 56. Don't always want to do this arithmetic, but once in a while it's okay. That's going to be -2 times 9/4 plus 18/2 plus 56. I'm doing this a little quickly because for me, this is not the most important part of understanding the graph. There's nothing wrong with just taking that function at the beginning and putting it into Desmos. What I'm trying to show you is the reason that it all makes sense. -2 times 9/4 is actually -18/2. Nope, I made a mistake. -2 times 9/4 is just -9/2. and then plus 18 over 2, plus 56. Negative 9 plus 18, so that's going to give me a positive 9 over 2 plus 56. And if I'm going to do this by hand, that's 9 halves plus 112 over 2, which is 121 over 2. That's the y coordinate. So my vertex is xy equals negative 3 halves, 121 halves. Or if I want to get it as decimals, so know what I'm looking at, negative 1.5, 60.5. And I know that my function opens down because a is negative 2. And so now I'd be able to sketch a graph with all the important pieces. Even if my scale doesn't make a lot of sense, I have an x-intercept at negative 7 and an x-intercept at positive 4. I have a y-intercept at 56. 60.5 is a little bit bigger than that. So that means this point right here, which is negative 1.5, 60.5 is my vertex, and it should be pretty obvious from the points that this function opens down. All right, that wraps it up for this video. Thanks for watching.